Welcome to Khetztutorials, and in this video, so this is the first video under Euclidean geometry, and in this video I'll be doing ratios and proportion. So let's just write that down so we don't forget what we're actually doing. So dealing with ratios and proportion. Now to start, we're just gonna do some basic ratios, or just to explain what ratios are, because this is going to be quite helpful when we move on to some other things like triangle geometry or theorems which are related to triangles. And so a ratio is simply a relationship, so some sort of relationship which we can form between two things. So let's say we have flour. So I'm just gonna make a general example. So let's say we have flour and we have eggs or something like that. So for every cup, so we're dealing with cups, for every cup, so 1 is to 2. Let's do something like that. So for every cup of flour, this is what this means. This is what this means. For every cup of flour, so for 1 cup of flour, we're going to add 2 eggs. Then what happens when we have, let's say, 5 cups of flour? Then how many eggs are we actually going to add? So to find that, you just say 5 multiplied by 2 and then divide by this one here. So whatever ratio you have, if you want to find the other one, you just basically cross multiply and divide by, let's say, a value which will be found here. And to find this value where we have a question mark here, basically just say 5 times 2 divided by 1, and the answer to that will be 10. So if you have 5 cups of flour, then you'd actually add 10 eggs, right? And that is what this relationship means, and that is how you basically apply your ratios. So a ratio is basically a relationship between two or more things, and the change in one variable or the change in one of the things affects the change in the other. And that is if you ask. So in a mathematical sense, if you're given, let's say, some sort of a line, and you're told that this is point A, this is point, so this is point A, this is point P, and this is point, let's say B. So now let's say the ratio of AP, so that's AP to PB. So the ratio of this part to this part is basically 2:3. So this is what this means. We're not saying, let's say we had this line measured in meters. We're not saying AP is 2 meters and PB is 3 meters. No. What we're basically saying is this AP takes up a fractional part of 2 of the total length AB. So we're talking about a fractional part, which is essentially just a ratio. And what that means is, or if you want to find, so basically we want to find the exact value of AP, given that the line AB, so AB, which is the total length, so let's say AB is given in meters as, let's say, 100 meters. Now, the ratio or the total of each of these, because this AB is formed of AP, as you can see, it's formed of AP and BP or PB. So then the total value, when you add AP and PB, you should get 100, right? But now you'll notice that this, you have 2 and 3. Now, if you add 2 and 3, you basically get 5, which confirms my point, which I said, or which I mentioned previously, that the 2 and the 3 are not the actual values. So this is not 2 meters and 3 meters, but this is the fractional part, or this is the fractional contribution of each of the lines to the total length, which is AB. That total length is 100. So to find the actual values in meters of AP and PB, this is what you basically do. So whatever ratios which you have in your, let's say here, 2 and 3 in our case, so you basically add these two up. So in our case, we have 2 and 3. We're going to add those up, and then we're going to say 5. Then you take the number which is associated with the line of interest or whatever variable of interest. So interest is in AP, and AP is given to us in the ratio as 2. Then we divide that 2 by the total which we got after adding the 2 values in the ratio. So 2 over 5, and then you multiply that by the total length of our AB, which is 100. We did the same with PB. It has 3, and then we divide by the total and multiply by 100. And therefore, this will give us the actual values of AP and PB. And therefore, 2 over 5 multiplied by that, so basically 1, and this goes in 20 times, and the value which you're going to get is 40, and here 120 times the value which you're going to get here is 60. So now if you look, 40 plus 60 is actually equals to 100, which confirms that indeed AP is 40 and PB is 60. And we found that using this relationship given to us in the question as 2:3. So the ratio of AP to PB is 2:3, but the actual values are 40 and 60. So I just use this line just to explain what ratios are and how you actually work with ratios. Now, when we work with ratios, we say that, so for the previous example, we say that AP is proportional to, so this is a sign for direct proportion. So we say that AP is proportional to PB, but for your purposes, it doesn't have to be directly proportional. You can just say AP is proportional, so basically proportional to PB. And this is just to explain the second part or the second term which we have in our topic, or which we have in our topic, which is proportion. Now when we talk about proportion, we are talking about it's basically almost similar, or they are similar. Ratios and proportions are quite similar. Now with proportions, we are saying that there is a certain relationship between the two. So for any change in one, the other one is affected. And now a ratio is just basically just a fraction or a relationship which can be represented numerically like that. You can also write 2/3 as something like that. So ratio is basically a numerical representation of a relationship, and proportion just basically explains that some values are related in a way. So both of these describe, so ratios and proportion, both of them describe relationships between two quantities. And you're going to see that we are mostly going to be dealing with proportions, but the proportions are given by the ratios given in the question. And if that doesn't make sense now, it will basically make sense when we get to that point. So now let's proceed to talk about a few things which you have to know. So let's now talk about the area of a triangle. Now the area of a triangle is going to be useful to us, or the principles which surround the area of a triangle are going to be useful to us, because from here we're basically going to deal with triangle geometry, how to analyze triangles, and to solve values, or to find anything to prove theorems and stuff like that. So to effectively do that, you have to understand the following. So the first point under this new subtopic of area of a triangle. So we know for sure that the area of a triangle is equal to half base. So this is base multiplied by the perpendicular height. So that is our basic formula for the area of a triangle. So it's half base multiplied by perpendicular height. And the first point says this height over here is taken with respect to the base. So if we have a triangle over there and we decide that this is the base, then the perpendicular height is actually going to move from the base to the top, or from the top to the base. So this is our perpendicular height. So if we had chosen, let's say we had chosen the base to be this point or this side, then our perpendicular height would be something like that. So that is what the first point says. The first point says the height is chosen with respect to the base. So you can basically choose any part to be your base for a triangle, and that is going to determine where the perpendicular height is actually going to originate. That is the first point, and we're going to move to the second point. And the second point says triangles which share a vertex all have the same height. So from point 1, we said that we are dealing with perpendicular height when we want to find the area of a triangle. And now I'm going to explain this second part which we have with us. So let's say we have a vertex here, A. So a vertex is basically just a point or a corner, if you want to put it like that. So if you have triangles, and I'm just going to use different colors just to show the different triangles which we have. So if you have triangles, say something like that. This looks terrible, but I hope you get the point. All right, and you can add in some letters so you can easily identify the triangles. A, B, C, D. We call this point E. So I have quite a few triangles here, but all of them, if you can check, they share this vertex over here. Now, from the previous point, we said that the perpendicular height originates from the base, or from the same line or the same level as a base. So let's look at triangle A, B, D, which is this triangle over here. You'll notice that if we choose the base to be this BD, so let's say base is BD, we are actually going to take this perpendicular height to be our height. Moving on to another triangle, let's say triangle ADE, choosing DE to be the base, which is this over here. You'll see that that same perpendicular height applies, so the same perpendicular height H. Now let's take a totally different one, which is quite far from these two, from this point basically, because ABD and ADE actually share this line, and it's quite easy to identify the perpendicular height which you're supposed to use in that case. But now let's look at something like AEC. So AEC is this one here. So for this one, you see that this line is slanted. So this line is slanted over here. This line is slanted, and therefore we can't use that line when we compute our area, because that is not our perpendicular height. But from the second point, we see that it shares this vertex A, and we can therefore use the perpendicular height H, which is over here. So for AEC, the perpendicular height is also H. And that was just to show you this second point, which says triangles which share a vertex all have the same height, right? We're now going to move to the third point, which is of importance to us, or the third point which you have to know. And that point says, so this is point 3, the point says triangles with equal bases and okay, so the triangles with equal bases found between parallel lines have equal areas, right? So triangles with equal bases which are found between parallel lines have equal bases. This is what this means, or this is a graphical representation. Let me just erase this. Here's a graphical representation of the third point. So if you have parallel lines, let's say these two lines are parallel, and you have a triangle over here, right? Let's say you have something like that as your triangle, and you have another one here which looks something like this. So it looks something like that, right? Just assume that it's in between these two parallel lines. Now, parallel lines are actually straight, or they're actually parallel. So which means moving from one parallel line to the other, you actually have a perpendicular height, h. So this perpendicular height, because these two triangles are actually found between these two parallel lines, they actually share this h, right? They share the h, and now that they share the h, coming back to the formula for our area, half base multiplied by height, so that is the same. The half is the same, obviously. You now have to check the b. Now the third part says triangles with equal bases, so we can say, so let's say we were given that this base is equal to that base. So these two lines just represent that these two are equal. You could use single lines as well, just so you basically know that the bases are equal. So now the bases are equal, and the height is definitely equal because it's a perpendicular height found between two parallel lines. And therefore, since all of the values are the same, so all of the values which you're going to substitute into the area formula is the same, which means that we are going to have equal areas. And that confirms our point, or that explains our point, which says triangles with equal bases between parallel lines have equal areas. So now we're going to come back to these points in a bit when we discuss some other things. So these are the points which you really have to know before we proceed. So let's just stop here for this video, and I'll continue the theorems in another video. So stay tuned for the next videos, and as usual, I'll also have a video dedicated to examples and showing you how to actually apply all of these things. So I will see you guys in the next video. Please don't forget to subscribe, like this video, and comment if anything isn't clear.